Until this point, that was their way off the pad if they needed to evacuate. But now with that arm retracting, the backup transitions to a launch abort system. And they'll begin arming that shortly. Of course, the launch abort system, great shot there of the crew access arm retracting away. The launch abort system is the tower at the top, and that's what would pull Orion and its crew off the top of the rocket in case of an emergency, whether it's on the ground or in flight. This is critical safety hardware that protects the lives of the astronauts. Starting at T-minus 6 minutes, the GLS will start bringing that and other high-energy systems online, starting with core stage pressurization. Weather is 90% go, the range is go, all systems are go. GLS is go for core stage tank pressurization. That means the replenish valve for the liquid hydrogen tank has now closed, and that tank is beginning to pressurize to flight levels because that hydrogen is naturally boiling inside the tank. We'll get the liquid oxygen tank a little later in the count. Now the team is waiting for verification that, if needed, the Artemis II crew could use the launch abort system to pull Orion safely off the top of the rocket in an emergency. Let's listen in for that call. GLS verifies last capability available. And CDR, you copy?
CDR copy, last available.
That's great news, and you heard the NTD verify that with the commander of the mission. GLS is go for FTSR. Now work is being done to arm the flight termination system. This is so the range safety can send a flight termination command if the rocket flies too far off track. There is a brief built-in delay, so the launch abort system has time to pull the astronauts to safety first.
H2 high flow bleed check.
All right, the high flow bleed check. And so the cryo team gets verification that the RS-25 engines, all 4 of them, are in the proper temperature range for launch.
GLS is go for core stage APU start.
Core stage APUs start. Those are auxiliary power units, high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25 engines. We're going to see a gimbal test a little later at T-minus 2 minutes and 30 seconds. This is what allows that to happen. Coming up in about 20 seconds, we're listening for go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve. This gets all the air and moisture out of there.
GLS is go for purge sequence 4.
Moving through the milestones. All is looking good. Coming up in just a few seconds, we're going to get that thrust vector control actuator test. This is a gimbling of the engines. There are the 4 RS-25s, 3 of them Shuttle Heritage, one of them built from shuttle parts. And there you see them moving. Now we're going to start moving the power from both the upper stage and the lower stage of the rocket to internal, taking ground power away and now going to battery power.
GLS is go for upper stage power.
Our power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery. Same milestone for the lower core stage coming up at T-minus 1 minute and 30 seconds. Right now, the four-person Artemis II crew is 248,000 miles away from the moon. And if all goes well, they will fly by it in 6 days.
GLS is go for core stage for internal power.
All right, there's the rocket's core stage, which houses 3 flight computers, is now on its own power. There's no more hold time because there's no more margin on these batteries. So we'd have to recycle back to T-minus 10 to recharge if we had a hold.
One minute.
Right now, the rocket does not know what the T0 is, but coming up at T-minus 33 seconds, control shifts from the ground launch sequencer to the rocket's onboard autonomous launch sequencer, or ALS. The rocket will count itself down, but honor any holds that could come from the ground. Now, shortly after liftoff, Houston will take control of the rocket, and my colleague Gary Jordan will take over commentary.
GLS is go for ALS.
Great call out. The rocket is on its own. 4 brave explorers ready to ride the most powerful rocket NASA has ever launched. Sound suppression water is flowing. And here we go. 10, 9, 8, 7. RS-25 engines lit. 4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
Good roll pitch.
Roger, roll pitch.
Houston, now controlling the flight of integrity on the Artemis II mission.
Integrity AMT high.
AMT high.
On time passing 30 seconds, 9 minutes. Integrity passes the alternate beacon. Target milestone. Mission control Houston seeing good performance and improved engines. Space launch system core stage. Integrity, 3 miles in altitude. Traveling more than 1,200 miles per hour. Mission last time, passing 1 minute, approaching max gear.
On, probably on.
Stan, we have you loud and clear on positivity on.
Have you the same?
Communication signal transfer confirmed as Integrity and its crew go supersonic. Approaching 90 seconds into the Artemis II mission. Integrity is 14 miles in altitude, 8 miles downrange, traveling more than 2,600 miles per hour. Seconds of mission elapsed time, standing by for main engine throttled down to 85%, and solid rocket booster separation expected at the 2-minute 9-second mark. We see throttle down. Confirm separation. Main engine's throttling up, guidance converge.
Guidance converged. Performance nominal. Upper stage RCS ready.
Copy all, Stan.
Integrity. SM priming complete.
Yes, I'm running complete.
2 minutes 45 seconds of mission elapsed time into the Artemis II mission. Thrusters on integrity and upper stage confirmed in a ready state ahead of service module fairing separation. Three minutes into the flight, integrity 49 miles in altitude, 78 miles downrange, now passing 5,000 miles per hour. Standing by for launch abort system jettison.
Houston Integrity, good last jettison, great view.
Copy jettison. TVCO 8+02.
We see the same on board, Stan.
And Houston has you loud and clear on TV at the common line.
Outstanding, Stan, we have the same.
3 minutes 50 seconds into the flight of Artemis II, Wiseman, Glover, Cook, and Hansen cross the boundary to space with good comm checks. GPS signals acquired after last jettison now working on internal checks to verify accuracy. Flight Dynamics Officer analyzed the time of main engine cutoff, confirmed at 8 minutes 2 seconds, time of MECO.
Integrity. GPS processing.
Outstanding, Stan, we see the same, and we have a beautiful blue rise. We're headed right at it.
Approaching 5 minutes into the flight, Commander Reed Wiseman confirms he has visuals of his destination. GPS guidance, navigation, and control software finishes internal checks and sends to navigation channels.
Integrity. 3 engine press.
3 engine press.
On time, now passing 5 minutes 20 seconds of mission elapsed time into the Artemis II mission. At this point, 3 good main engines are all that's needed to carry integrity to a nominal main engine cutoff target. Though at this time, we're saying 4 good engines here in Mission Control Houston. Integrity, 75 miles in altitude, 330 miles downrange, approaching 10,000 miles per hour.
Integrity. Looking good at 6 minutes.
Same on board, Stan.
Good trajectory and engine performance. Booster officer will soon report the shutdown plan to Flight Director Judd Freeling, expected at the 7-minute mark. Integrity, 78 miles in altitude, 460 miles downrange.
Integrity. Expect nominal shutdown.
Integrity copies nominal shutdown.
Six minutes 40 seconds of mission elapsed time. Shutdown plan is as expected. Again, the time of MECO was confirmed at 8 minutes 2 seconds into the flight. Seven minutes of mission elapsed time. Throttling down as we approach the abort once around option. Milestone at the 7 minute 30 second mark. Now 84 miles in altitude.